Hello everyone. Today we are going to continue on with our circuits unit. Today we are starting on electrical current. So let's talk about what current is. So think about where you may have heard the term current used before. We'll think about what current in a river describes and compare that to electrical current. And we'll see what causes the current in a river to flow compared to something like a circuit. So if we take a look at our regular streams and rivers flowing down mountains, usually that's going to be gravity that carries it down. So it's going to have potential energy at the top, and by gravity, it's going to pull it down to the bottom. Now, let's take a look at electrical current. So electrical current is the rate at which charge flows through or past a given point. So this may be in a circuit, it might be through air. We'll see there's a couple different examples. Electrical current is going to be caused by electrical potential difference or voltage between 2 points in a circuit. Now this can be different than a current of a river, which is driven by a difference in gravitational potential energy. For current, the unit that we're going to use is an ampere, or you may also hear it referred to as amps. We're going to see that 1 ampere is going to be equal to 1 coulomb per second. So all abbreviated, be 1 capital A is equal to 1 capital C divided by S. Now let's take a look at the equation for current. This is also in our reference table. It's going to be I equals delta Q over T. In this case, I is the standard symbol for electrical current. If you remember that delta Q is our unit for charge in coulombs, and T is still going to be time in seconds. So we can see how on the left side it'll be amps, and on the right side coulombs per second, working out to exactly what we thought it would. Okay, so the rate of charge flows in a couple different places. So electrical current through circuits and wires. We'll see in particle beams and streams of ions are all different places in which these currents are going to be flowing. Now, let's take a look at some charge carriers. So different phases of matter are going to require different means to pass this current. So we have our 3 phases of matter: gases, liquids, and solids. For gases, this current is going to be carried by negative ions, positive ions, and electrons. In liquids, this can be carried by negative ions and positive ions. And in solids, this can be carried by electrons. So you may have heard of some of these different terms throughout chemistry. Mainly what we're going to be looking at is solids, in which this will be carried by electrons.
All right, so now let's take a look at an example in which we'll be using our new formula for current. So in this example, we have 100 coulombs of charge that pass through this point A every second. So we want to find out what is the rate of current flow through point A. So we're going to use our new formula for current. I equals delta Q over T. And it says it's going to be 100 coulombs of charge per 1 second. So that is simply going to give us 100 amps for our current. Now let's take another look in which we're going to use current 2. So in example 2, during a thunderstorm, a lightning strike transfers 15 coulombs of charge in 1 times 10 to the minus 4 seconds. What is the average current produced in the strike? So we have this transfer of 15 coulombs of charge in a time span of 1 times 10 to the minus 4 seconds. We want to find out our current. So write out our equation. I equals delta Q over T. Plug in our numbers. 15 coulombs divided by 1 times 10 to the minus 4 seconds to get a total amount of current equal to 1.5 times 10 to the 5 amps. Or we can rewrite this as 0.15 mega amps. In example 3, the current traveling from the cathode to the screen of a TV picture tube is 5 times 10 to the minus 5 amperes. So we can write out our current, I equals 5 times 10 to the minus 5 amps. And I want to know how long does it take 1 times 10 to the minus 3 coulombs of charge to accumulate on the screen. So here we have our delta Q to be equal to 1 times 10 to the minus 3 coulombs. We want to find out our time. So we'll start off with our formula I equals delta Q over T. We want to solve for our time T here. So we'll multiply T to the other side, divide by I, and figure out this new formula. Now we can plug in our values. So for delta Q, it will be 1 times 10 to the minus 3 coulombs, divided by our current, 5 times 10 to the minus 5 amperes. And if we remember, amps are equal to coulombs per second, so the coulombs will cancel out, and we'll end up with seconds on top to get a total amount of time equal to 20 seconds. Now in example number 4, we have a wire carrying a current of 50 amperes. So I equals 50A. Now how much charge passes through the wire in 10 seconds? So we have a time of 10 seconds, and we want to know the amount of charge, Q. So we'll start off with our formula, I equals delta Q over T. We want to get delta Q by itself, so we'll multiply the T across and get this new formula. Now we'll plug in our values. I is equal to 50 amps times the time of 10 seconds. And we'll get a delta Q equal to 500 coulombs. Now, for the next question, it wants to know how many electrons pass through the wire every 10 seconds. So we'll have to convert our units from coulombs into elementary charges to find out how many electrons there are. So we can do this by saying we have 500 coulombs. And then from there, one elementary charge is equal to 1.6 times 10 to the negative 19 coulombs. Throw that into our calculator real quick. We'll get 3.125 times 10 to the 21 elementary charges, which is going to be the same as the number of electrons. All right, so that's going to be it for current. I hope you all have a great rest of your day.